Hi guys, guess who it is? Kim Kardashian! No, it's Mr. E. I'm not Kim Kardashian. No, I work for a living. Anyway, we're gonna go ahead and do another section video about distance formula with the Pythagorean theorem. So I hope these videos are helping you guys out. I would recommend that if you have the notes, have them available for you guys to read while we are going through these notes via video. And if you have any questions at all, don't hesitate to shoot me a message, give me a call, etc., whatever you have to. So distance. We are going to be sort of using our coordinate grid, but I want to make a very big note for those of you who are relying heavily on our slope formula, rise over run. Distance is not the same thing as slope. When we were calculating slope, we were calculating the steepness of a line. That is, how steep is a line if we are going up it or going down it. Is it a heavy incline or decline? Is it a easy incline or decline? Where distance is the actual length from A or B. So I wanted to make sure that was very clear for you guys to understand. I know that we didn't get a lot of time to go over that when we were doing coordinate grid, but no time like the present. So why is the topic distance formula, but we also throw in Pythagorean theorem? Well, the answer is that we are given a line from A to B, find the distance. However, we can use Pythagorean theorem to find the distance if we were to draw a flat line from A underneath B and then go up it. It's kind of like additionally drawing a few more segments with a line so that we make a right triangle. So what happens is we find our starting point and we go across horizontally until we are underneath the point of our destination. Then we draw a vertical line going up. These two lines that we drew are perpendicular lines, meaning they're going to make a right angle. So when we combine it all together, it looks like a right triangle. And what do we use with right triangles? Pythagorean theorem, which is a square plus b square equals c square. So we use that by determining what was the distance we made when we drew these additional lines. So we had our starting point, and we go across until we are underneath the destination, and that would be 4 points across. Because right here we start at point 33, and then we end over here at point 73, and that means we go 4 units across. So the length of this side is 4. Here, when we go from where we left off straight up to our destination, we go from point 73 to point 63. Wait, hold on. Oh no, I'm sorry. I'm looking at the wrong space. 76. So we go from 73, this point right here, to point 76. What I did right here is I showed the math from our destination position and subtracted from our start, and then we get 3. That is the length of this additional side right here, 3. So the bottom is 4, top is 3. So now what we can do is we can plug these two numbers in to a square and b square so that we can use our Pythagorean theorem to find the value of x. And this should be really easy from our last video because, as I've said, we got 3 squared, 4 squared equals a number, which if we did our math, add up to 25 equals x squared. A number, when squared, will give us 25. A number multiplied by itself will give us 25. And that answer is going to be 5. 5 squared is going to be 25, so x equals 5. So going back over to our chart here, if we follow the method using Pythagorean theorem, we see that the distance from A to B, this green line right here, is going to be 5 units. That's really all we need to find there, is the distance from A to B, 5 units. We just use this Pythagorean theorem method to help figure it out much more easily. However, we do have a formula you guys can follow instead if you don't want to do all that extra work. However, if you're a visual learner and you have a coordinate grid in front of you, this is a handy dandy tool to follow. But before we get to the formula, let's follow another example. We're given 2 points, E, which is -2, 5, right here, and F, 3, -4. There it is. What's the distance between the two? What is the value of X? So we can actually begin mapping it out. So E is our starting point. Instead of going horizontal this time, I mean, we could do horizontal and then vertical. However, I decided to go the optimal route where we went down first and then horizontal across. What can I say? You can take the teacher out of the rise and run setting, but you can't take the rise and run setting out of the teacher. So this is just my method. You guys can do it the other way where we went horizontal first, then vertical. But for this example, I decided to do the opposite way, just in case. So, looks like here, the notes say we can go horizontal across. So, we go all the way across until we are directly underneath our destination, which is E. And that was 5 units across to get from 3, -4 to -2, -4. Now, I know that we went left on the x-axis, so there should be -5 or 5 to the left. But since we're doing Pythagorean theorem, it really doesn't matter in this case, because even if it is a -5, if we were to square that, it would still equal 25. Don't believe me? Okay, if you don't believe what I'm telling you, take a calculator out, type in -5 times -5. You guys should still get 25 in this instance. So if you are covering Pythagorean theorem finding the distance, don't worry so much about the sign in this given instance. You will still get the same length. So 5 across, so it's just going to label that the measure length of that base as 5. Then go all the way up to E. Goes from this point, which is -2, -4, to E, which is -2, 5. If you count the steps, you should get 9 units up. So 9 units up. So we have our a square and b square, or a squared, b squared, depending on your preference. So let's plug it into our formula. A square plus b square equals c square. 5 square is going to be 25, and 9 square is going to be 81. Add them all up, you should get 106, which equals x squared. We're almost there, not quite though. We need to find what number that when squared is going to give us 106. And I will tell you this, 106 is not a perfect square number like 25 or 36 or 49. It will come out as a decimal answer if you tried to type it on a calculator. So you can actually generalize your answer by just putting the square root symbol above 106, and the same thing of your x squared. What happens here is this x squared becomes x because we got rid of that second power, and then square root 106. I will accept that as your answer. Unless you want to actually type in a calculator and give me the decimal answer, I will accept this type of answer as well. Just set it up as what's called a radical. So radical 106. So there are a lot of easiness. Don't let the square root function really freak you out. You can just generalize it as long as you take it baby steps. If you have any questions, feel free to message me. Now, here's that distance formula I was telling you about. If you're a formula master and prefer to just have a cheat sheet, easy way of doing it, then this would be the formula for you. Sorry guys, I guess my thumb slipped a little bit, so I didn't get a chance to finish up. So basically, if you're a person who wants to use the distance formula instead of doing all that extra work with the Pythagorean theorem, you can use this method as well. So what you can do here is our distance formula is x2 minus x1 square plus y2 minus y1, and then square that. So we're gonna go ahead and take this example right here. We're gonna have, 1 sec, 2 points. So let's say that, yep, we have 2 points here. 3, 4, that's point 1. And then the second point is 6, 10. We need to find the distance between these 2 points. And again, this is 1 point. That's another point. Find the distance between the two. So the x's are gonna go in one box of parentheses together, the second one always being first. So the destination, its points are going to be written first, and then the starting point coordinates are written after. So this is where the x's go, and this is where the y's go. So x minus x, do that difference and then square it, and then the y's, destination, start, subtract that, square it, add them all up, and then what you're gonna do is you're gonna square root the whole thing. So hopefully you guys have a square root function on your calculator to find that. But again, I already did the math over here for you. So 6 minus 3 square plus 10 minus 4 square. 6 minus 3 is going to be 3 square. And then 10 minus 4 is 6. So we're going to square these now. 3 squares 9. 6 squares 36. Add them all up, you get 45. Then you can either use your calculator to find the decimal answer, such as what is the square root of 45, get a decimal answer, or you can just write your answer as a radical 45. And that's all it is. So yeah, distance formula is right there in case you need it. If you're on the test, you guys will probably have this formula available to you. But that's pretty much the gist of how you do it. There is a worksheet, obviously, that goes along with this. And I guess in this section, I'm going to be uploading 2 videos since there was a little snafu with the recording here. And yes, I am recording it on my phone. It's a lot easier than buying a camera and bringing it out here on a nice sunny day. I hope you guys are enjoying the weather as well. So once we get more of these sessions in, I hope you guys will look back on these videos to help you guys remember how to do all these a lot more easily. And I hope you guys print out all the notes that are available. If you have any questions at all, don't hesitate to call me or shoot me a message. Any way you can contact me. All right, you guys have a wonderful day. I'll see you soon. Bye.